Sehr geehrte Damen und Herren, welcome, ladies and gentlemen, at this, in my opinion, most beautiful civic space in Basel. We're incredibly happy to be able to sit here in this wonderful and unique building. And we say thanks already to our friends and colleagues from the Theater Basel who are hosting us here very generously a couple of times already. So we've had debates in here, and I can tell you, the space is intimidating. When you sit here, you really know you have to get your act together and talk straight. It's so impressive to see the ceiling over you. But the ceiling is out of concrete and the rest of it as well. So it is very, very fitting for our debate. We have a complex scenario, of course, with COVID, with a split setup between the physical space and an online space. And we can explain you this in a moment. Andreas, my colleague, will do this. And Andreas Kofler is the Deputy Artistic Director of the Swiss Architecture Museum and curator, also co-curator of the current concrete show that you may have seen already. And if not, I think you will have a chance even tonight after this event, if you're so, I don't know, motivated or scandalized to deepen your knowledge about concrete, then you can do that. And I would like to hand over the speech to Andreas to introduce our guests.
Thank you, Andreas. Yes, we have a very interesting number of guests here tonight. I will briefly try to introduce them, which is quite a challenge because I think by reading their CVs, we could fill a whole evening. I start with, on the right of Andreas, with Professor Dirk Hebel. He's Professor of Sustainable Construction and the Dean of the Department of Architecture at the Karlsruhe Institute of Technology. Prior to that, he was Assistant Professor of Architecture and Construction at TH in Zurich and Principal Investigator of the Future Cities Laboratory in Singapore. He's also the author of numerous books, and I'm mentioning just one of them tonight. It's Urban Mining und Kreislaufgerechtes Bauen, Urban Mining and Circular Construction. And not least, he's co-founder and partner of 2HS Architekten and Ingenieurpart GmbH, Hebel, Heisel, Schlesier. You're all free to add or correct me if I'm missing something or if I'm spelling out something wrong. Next to him, there's Christine Binswanger. She studied architecture at ETH in Zurich and then joined Herzog & de Meuron in 91, became a partner in 94, and then a senior partner in 2009. She also received a very prestigious prize, the Merit Oppenheim Prize in 2004, in recognition of her active leadership in the architecture and art community. And she is and has been in charge of many museum projects, urban development, civic planning, and housing project at Herzog & de Meuron. Amongst them, there's also a project, the 1111 Lincoln Road in Miami, a mixed-use structure for park, retail, and restaurant and private residence, which actually is quite a grandiose concrete building. So I'm allowed myself to mention it here tonight. Next to her, there's Edelio Bermejo. He studied material science at the Polytech in Paris. He holds a PhD in material science from the Université Pierre et Marie Curie. And since 2019, he's group head of research and development, innovation, and intellectual property at the Holcim Innovation Center based in Lyon. Next to him, there's Friederike Kluge. She studied at the University of Karlsruhe, is a former collaborator of Buchner and Bründler, and also former assistant and lecturer at the professorship of Anne Speer at ETH Zurich. Now she's herself a professor of building construction and design at the University of Applied Science in Constance.
And in diesem Herbst geht sie an die FHNW, kannst du noch sagen?
And starting from this autumn, she's at the FHNW in Basel. But we're also greeting her students from Constance because we know they are following us to the webinar tonight. Good evening. She's also founder of Alma Maki together with Mike Rehrmann. This was done in 2014. And more importantly, in 2019, her office joined forces with other architects from Basel and founded the project Countdown 2030 with the aim to make all those involved in construction aware of the impact of their professional actions on climate change. And next to her, there's our fifth guest. This is Philipp Block. He studied architecture and structural engineering in Brussels and at the MIT, where he also earned his PhD from in 2009. He's founding partner at Oxendorf de Jong and Block Engineering, and he's professor at the Institute of Technology at ETH Zurich, where he co-directs the Block Research Group, which focuses on computational form finding, optimization, and construction of curved surface structure. And this is also probably why he's director of the Swiss National Center of Competence in Research in Digital Fabrication too. Okay, this was very fast. I apologize to sum it up this way. I also greet all our 200 exactly participants at the webinar already. This is quite a nice number. They can, or you can virtually raise your hand during the webinar. You can submit questions to the Q&A. You can directly send messages to me. And this is also why I apologize. I may look like a bored teenager here in the corner on my laptop, but I'm basically an avatar for those people who follow us online, and gonna try to introduce these questions then to our discussion. As a little disclaimer for those online, you can also join us live, but the event is being registered and will be available on our YouTube channel afterwards. Last but not least, we greet obviously the people in the theater. They will also be able to ask questions later, but they can also leave us a more anonymous kind of messages. You all found some postcards on your chair tonight where you can leave us your opinion, what concrete is for you. Thanks.
Super. Vielen Dank. Thanks, Andreas. Before we get into the event proper, I would like to thank our main sponsor, Holcim Ltd. It's the global affiliation of Holcim, which also has done local affiliations here in Switzerland and many other countries. We decided to work together with Holcim for this event very, very consciously, because we want to make not only this kind of look back to the golden age of Swiss architecture, concrete architecture from the 19th and the 20th century, but also you want to look forward. The reason why the exhibition that you may have seen really focuses on the past has to do with the fact that all the pieces that you see, or most of them, are coming from three main important architectural archives from Switzerland, in the ETH Zurich, at the EPFL Lausanne, and at the Swiss University of Ticino in Mendrisio. And as archives are, they don't go quite up until the very present. They need some waiting time to evaluate if something is archive worthy or not. So their collections really kind of started in the 1980s, and that's why the exhibition kind of tells the story of concrete until that time. Now, we all know that from 1980 until today, in these 40 years, the entire evaluation of concrete and how we come to look at this material has changed quite a bit, especially in the last 5 or 10 years, where we had the feeling, but there's a kind of change of paradigm. At least in Switzerland, it was kind of the standard answer to make a building in concrete. It seemed the natural choice to do, and I've seen many Swiss architects giving presentations of their work where if they had to present a project that wasn't done in concrete, they actually started to apologize for it. So much obvious was that kind of choice, and it's no longer that obvious. Obviously, it's concrete has come into question. You actually today you need to almost apologize if you make a concrete building, not the other way around. And there's a big question mark as to how is the future of this material. It's still the most used building material in the world, and at the same time, it is responsible for 8% of all global CO2 emissions. That's more than all air traffic, which is 3%. But it's less than mobility, ground mobility, which is, I think, 30%. So there is the big question, what do we do with concrete? Can we still continue to build with concrete like we did in the past? And there's heated debates about this, and it's almost as if you talk about vaccination. There's either pro or contra. There's nothing in the middle ground. And also, like with vaccination discussions, rationality sometimes is hard to come by with. And that's why today, the goal of the event is to really expose different attitudes as to the possible future of concrete. And we will have various protagonists speaking in favor of the possibility of a future in concrete, and various others who are maybe more doubtful and would stress alternative scenarios. And I think all these takes have the validity, and the goal is not to shame anyone for thinking whatever they think, but really come to terms with what has changed with concrete, what will change with concrete, and how can we relate to this situation. And to kind of lead into the debate, we thought it's maybe helpful to have three compact, quick intro presentations that highlight one or the other stance and maybe something in the middle as well. So I would like to ask Edelio Bermejo first to go to the stage and to give a short quick on how at Holcim Research and Development they are trying to reinvent this material and to make it compatible to the needs of society about concrete today. Edelio.
Thank you very much. So thank you.
Oh,
so first of all, I feel very, very honored to be here in such building, which is quite amazing, made of concrete. So wow, an impressive concept that's showing that definitely the way concrete has been built in the past has nothing to do with what the building will look like in the future. And that's something that I would like you to remind tonight after this speech. So the reason why it will be very, very much different, it's first of all, because the way we are living today, the world is changing. It's changing. And if we look at the very basic trends that thanks. The very basic trends that we're facing today in the world, I will not go in depth into these ones. You know them. But just to remind them that these facts are changing, are shaping the way we will build, and we are building today with concrete. First of all, the rising population and urbanization. By 2050, 2/3 of the people will be living in cities. So we need to adapt the way we build. The population by itself, 10 billion by 2050. So we need to accommodate all these people. And we need to think the way we build the cities in order to adapt to this population. 2.3 planets will be needed by 2040. That means that again, it's not extendable. So we need to adapt the way we are tackling with the natural resources. And we know that in order to make concrete, we need natural resources. So we need, here again, to change the way we make the cement and we make the concrete and we use the concrete. The climate, the race is on, so we need to adapt. And there will be some effects. The weather will be changing. The hurricanes, the different events, climate events, will force us to adapt the way we are building as well, because we will need to have resilient systems to face these events. And the last point, which is adequate housing and sanitation, 1.2 billion by 2030 will need this adequate housing. 2030, that's tomorrow. And this is the decade we need to absolutely change the way we build. The reason why Holcim is taking the lead on building the way we want to use, or on changing the way we want to use concrete, is based on these 4 key levers. First, we need to use low carbon products. That's mandatory. And we are already changing this. Second, circular construction. There are so many wastes in the world that we need to adapt and to reuse this waste in the way we are building and the way we are using concrete. And I will come back to that. Smart design and systems. We need to change the way we think, we design the building in order, again, to adapt and to face the 4 facts that we already mentioned before. And the next generation technologies. We need to adapt and to take into consideration the way we are today extracting data, generating data, and extrapolating and modeling the way we build. So I would like now to spend a few minutes on each of the 4 pillars that I'm mentioning here. The first one is on the green building. Low carbon solutions on cement, on concrete. We need to redesign, to rethink the way we are producing cement. We need to replace the clinker, which is a raw material for the production of cement. So we need to minimize the use of the clinker in the cement formulation. And then we need to use alternatives, be it slag, be it fly ashes, pozzolan, or natural resources or waste materials that are existing today and that are to be used anyway for the production of cement. So here I'm just mentioning two products that have been launched by the group, Holcim, which is leading in this green solution and providing a quite broad range of green cement and concrete with a decarbonization, a reduction of CO2 ranging from 30% to 100%. That's our way to decarbonize the industry of cement and concrete. Products that have already been used. So we are not inventing something for tomorrow. We are already using today these products. A few examples in Seattle with the spheres, very iconic, very beautiful, with a reduction of CO2 of 80%. That's a building that has been done for Amazon, and that's quite nice. You can see that it's a very, very iconic, and leaving the freedom for the architects to think differently to make something very, very nice and cool with concrete. Another example, the iconic tower in Egypt, using a cement, which has a 50% reduction carbon footprint compared to conventional cement. Or the example in London with the 8 Gardens, with again EcoPact, the range of low carbon concrete, reducing the carbon footprint of the entire structure of concrete by 64%. We need to make them aware because you will be using these products. The architects, the designers, the masons, everyone has to use these products. But in order to make them aware, we need to, first of all, promote it. We need to make sure that all the stakeholders and the policymakers, the public procurement, can have access to the information. So obviously, having a digital EPD, environmental product declaration, having a digital information easily accessible is extremely important for the awareness of such products. Making them aware is a part of the solution that we're today developing with the Solar Impulse Foundation, the one led by Bertrand Piccard, which is the label that we got for these products, which is again increasing this awareness. The second lever that I mentioned before is very much about the circular construction. We are, all of us, generating a lot of waste everywhere, and we need to get rid of this waste. Today, the cement industry and the concrete industry can cope with this waste, either in using that as an alternative fuel or either using that or reusing that in our own products. The concrete demolition waste are recyclable, and we recycle them by using them as a raw material for the cement industry or for the concrete industry by just reusing them as a recycled aggregate. Obviously, the best example we have today, it's in Switzerland, in Zurich, with the Susteno brand, which is a cement containing 20% of recycled aggregates crushed and made as part of the cement together with the raw material, the clinker that I mentioned before. That's unique. That's something which is not existing anywhere else in the group. We started with the Swiss model, and then we are replicating this Susteno brand with the concrete demolition waste inside all over Europe and then the rest of the world. Other examples, the digital material management, which is making sure that the available information about the recycled aggregates, the concrete demolition waste, is well known by all the users, and then they can easily have access to this material. Advanced crushing technology. Let's imagine that tomorrow, instead of having just recycled aggregate, we can separate the aggregate, the paste, and the cement. And then you can have a better access to sand. And we know that sand is scarce in some areas. We can have a very, very good aggregate, very clean, which is then replacing natural resources and the conventional aggregates that we're using. Smart recycling hubs is how to get access to these recycled aggregates more easily and available for everyone. So a key trend with an objective to reach 100 million tons by 2030. And among the 100 million tons, we want to use 10 million tons of these concrete demolition waste to be reused in our industry as a recycled aggregate or a material for cement. Obviously, making the products low carbon is a solution, but having a design which is by definition using less material, with the material at the right place, with the right composition, it's extremely important. That's what we did with the Striatus bridge that has been exposed in the Biennale in Venezia, in Italy, which is a bridge made of 53 blocks, all different, designed and produced by 3D printing, empty inside. That's a wall. And then all them just combine, but not glued, but just combine all together by gravity, which is making them extremely unique, recyclable, obviously, dismantleable and reusable again. So having by design this spirit of already anticipating the fact that it will be either reused and then dismantled, either recycled, and then optimizing the use of the material over its life. The second example with the lightweight floor system that Philippe knows extremely well, which is just putting the material at the right place and not more. Instead of having a slab which is absolutely plain, so having this kind of slab with a lot of holes, but still supporting the strength, still supporting the constraints that we need for a kind of slabs. Obviously, repairing, renovating, the best way to lower the carbon footprint is not to destroy or to demolish and to rebuild, but it's just to avoid the demolition and then to extend the shelf life of a structure by renovating. And we know that 80% of the buildings that are today built will still exist by 2050. So obviously renovation, repairing will be a key part of how we could lower the carbon emissions by avoiding new construction. Obviously, the new generation technologies, that's the fourth pillar of my first slide, is how could we define new ways of either avoiding the emission of CO2 by just making sure that the CO2 at the chimney of the cement plant is not emitted, by capturing it. So that's what we call the CCUS, carbon capture, utilization, and storage, is how can I reuse the CO2 which is emitted from my chimney into something new, not just avoiding emitting that in the air, but reusing the CO2 for synthetic fuel production, or even crop growth in vertical farming, as we do in Andalusia in Spain. So how can I get use of my CO2 emitted from the chimney in order to produce something and not just letting them going into the cloud? Timber rock. Timber rock, it's a perfect combination of wood, taking the benefits of wood combined with cement, and then having cheap woods replacing the aggregates, and then combining the aggregates, these cheap woods, with cement in order to make a new kind of concrete, which is carbon negative first, and supporting or leading to the same functionalities that a conventional wall. Third one, very new, magnetizable concrete, just to have an inductive charging of the battery of your car, electric car, but without any wire. While the car is in function, on the road, it's charging by induction. That's something which is quite new that we did launch in the last few months with a collaboration with a startup, a German startup called Magment. And the last one, artificial intelligence. We're generating a lot of data. You are generating a lot of data. How can we extract the most from this data in order to generate a lower carbon production, a process of making cement, a process of making concrete, a prediction of a modeling of the performance of the concrete by using all these data. That's the key challenge for the coming years, and we really need to be ready for that. Obviously, we want to lead this industry to the net zero transition. And then we have to be prepared for all the areas of applications where concrete is absolutely needed, be it for housing for all, making the houses with a lower carbon footprint, embodied carbon footprint, the green infrastructure. Here you can see a fantastic example of reefs of bioconcrete, which is that's made with 3D printing that will be in the sea and that will be restoring the fauna and the flora in the maritime environment. Industrial, obviously we're building a lot of industrial facilities worldwide, be it from logistics or energy systems, and then we really need to answer to these needs. And obviously circular cities, making sure that we are improving the way we are defining these the circular dimension of every single city which is built. So all in all, the message here, and I will be extremely happy if at the end of this presentation you keep that in mind, is that we are building and leading the industry towards a net zero transition, a net zero transition that has to be known first by you, because you will be deciding the way you want to build. And obviously you have to remind that the low carbon solutions is not something for the future. That's something which is already existing. We have to make it aware. This is our job. We are making that aware with a lot of events like this one, just to, for you, consider that concrete is not something from the past, but we're moving to something which is low carbon and in the future, absolutely net zero.
Good, thank you.
Thank you very much.
Mm-hmm. We continue with Philippe Bloch.
All right. Thanks for this opportunity. Sorry for bombing the program, but after we talked, Andreas, you said it sounds like you have to present as well. So thanks for that. All right. All right, I will be talking about rethinking concrete construction, and more specifically, I want to demonstrate what you can achieve by strength through geometry and also by material effectiveness. I'm not talking about material efficiency, so you will see that this is different. My work starts by researching historic structures, and the more you actually look at them, you're entirely blown away that modern day tools can actually barely understand, explain, design how and why these beautiful structures still stand, particularly when you realize that they're proportionally as thin as an eggshell. So in order to share that message in 2016, we tried to shake the community a bit, our profession, to show such a structure, 399 cut stone pieces held together by geometry. They get strength through their geometry. There is no glue, no mortar, no reinforcement. So this extremely thin sheet of concrete, why I show you this, of stone, why I showed you this project, you will see this all come together later. But the key thing is that by reintroducing good geometry, structural geometry, you can reduce mass. Another old project that I was lucky to be involved with in Interpretive Center in Mapungubwe in South Africa. What is special here is it's an other advantage of actually getting the geometry right. We used extremely weak materials, so weak that they had to be brought on site in very small packages, or otherwise you can just break these elements. But if you see on the left, if you place these weak non-structural materials where the forces want to go, like historically people understood, then it's a perfectly safe structure that carries the floor still today. So the key message here is that you not only can reduce the volume, but also reduce the stresses. And there is almost a one-to-one relationship between how much you're asking from a material and how polluting it is. So that is the important message here. So we heard about this. We have quite a challenge as a profession ahead of us, a gigantic world population increase. Typically, you hear about this equivalent building of one New York City every month for the next 40 years. Another calculation is that we are expected to build about 200 billion square meters of floor area in those next years indeed. So looking at these buildings, so we most likely will densify. We will go a little bit higher. I'm not suggesting that this is the future, but let's take any of these buildings. What is remarkable, if you look at medium high rises, then you see that 3/4 of the mass of those buildings is in the structure. So totally crazy situation. The structure is mainly there to keep itself up. And if you then zoom in a little bit more, then you see that actually more than half of that structural mass is in the floors. So spanning space, providing the most banal thing to walk on that we all need in buildings is actually really the most material intensive component. That is why we actually are now recently translating these ideas to address this big challenge. Can we do something better? You probably can imagine where this is going. I consider concrete, so we also need to distinguish concrete versus reinforced concrete, but concrete is like an artificial stone. Stone is happy in compression, not in tension. That is why these structures are all vaulted arches and so on. So, and indeed, if you do that, if you reintroduce the stiffened arch with a tension tie, rather than pushing a material in a geometry that it absolutely does not want to be, like a straight beam or floor plate, then for free, and this is just bringing back old principles, known principles that have stood the time, you get 70% less concrete and 90% less reinforcement steel. So we thought, okay, great. Can we then modernize this rather than just these simple arches? So we made a 3-dimensional floor plate that we also already showed in 2016. The same idea, the vault is there to carry the weight very evenly, like an Islerschale, very optimal, will stand for thousands of years. And then the stiffeners are basically there for live load cases. So here's some images of some early prototypes. This is the very first one we did in 2011 that we then broke just to show how thin this unreinforced concrete floor plate is indeed. In order to, again, I've now spent almost 10 years of trying to convince many skeptics that reintroducing old knowledge actually makes sense. We do extreme things like this, 3D print, a floor with a super weak material that also, again, you can break as easily as cold dark chocolate in your hands. So we do all the required tests, and then we also, as any engineer, you want to go stand on your structure. So this is 1,200 kilograms of ETH nerds standing on a 2-centimeter super weak floor that is nicely stable. If you think that this is very academic and crazy, what are you talking about? Unreinforcing today, this is not possible. Then maybe you should go to the Oyster Bar in Grand Central Terminal in New York, or perhaps on top of that, because these structures have the same thickness, the same weak, proportionally the same weak materials, and they're carrying the Vanderbilt Hall on top. So if you think that I'm crazy by proposing these super lightweight, unreinforced structures, then we should warn the millions of New Yorkers going to work every single day that they're in danger of their life. You might have seen this absolutely crazy thing. That is the last thing that we finished, the high-low project. The roof is there to shout and make you pay attention. I mean, we did something special with the roof as well, but I want to talk, the key message is the floors. Because the floors is the first time in a real project, an approved project, an engineered project, that we built such a floor, an unreinforced, super lightweight floor that for the 5 by 5 meter span has only 3 centimeters of unreinforced concrete and then these stiffeners on top. So I show this because I know what the outlook could be. If we again go back to these structures and we take any of these medium high rises of roughly 25 stories high, if you then were to do a simple case study, combining those two aspects that I already talked about, that 40% is in the floor and that you can have the savings on the right. Those of you paying attention, it's no longer 70 and 90%. That is because we're talking about a building that has higher fire regulation requirements and so on. So we need to compensate for that a little bit. Still, I would say those are some pretty nice savings to be gotten. So for this one building, you would save 7,500 cubic meters of concrete. If that is a bit abstract, that translates to more than 1,200 concrete trucks that don't have to go to this one building site. But, and this is important in this discourse, it's not just about the concrete. We also save more than 20 kilometers of reinforcement steel per floor, which then nicely comes to this coincidence that it goes from Zurich, where I live and work, to Brussels, where I'm from. So that is a lot of reinforcement that you're saving on this building. Okay, but what really matters is not lighter, less material, and so on. So we need to get past that. What we really need to address is these extremely painful statistics. That is what we are responsible for globally. 40% of emissions, resources, waste, and then also energy use. So let's talk about the gray elephant in the room, and let's talk about this most destructive material on Earth. So everyone seemed to agree that this material is extremely bad. But is this really the right statement? Is this really a question about material? Many researchers before me have indeed demonstrated that concrete is not a bad material when you look at the energy. Absolutely not bad when you look at the embodied carbon coefficient, so the emissions associated to it. That's what really matters. You see there on the left, the only material you cannot touch is sustainably sourced timber. And then we probably will have a bit of a discussion about what it means to provide timber at the scale that we need to still provide adequate housing globally. What does it mean to keep it sustainable indeed? What does it mean to actually not lose all the benefits of the timber at the end of lifetime when you trash it end? All right, so this is what matters. Sorry, it's one equation, but I think it's pretty cool. It basically says what really matters when you look at embodied emissions. So this is an equation that first was written by Catherine de Wolf, new colleague at ETH. So she says that you want to take all the parts in your building, and then, so the first thing is you have the mass. How much material are you using? Then there is the ECC, that is how polluting, embodied carbon coefficient, how polluting is that material. And then recently also the time scale was added, but I will talk about this later. So here, going back to the floor. Okay, now this is gonna be a little bit too much, but I wanted to actually, this slideshow shows you that if you only innovate on the material, because you also have the steel, because you have all these other aspects to your structure, you actually save 30, maybe 40% of emissions. But if you introduce strength through geometry, then you get two benefits at the same time. Remember the Venice project, the crazy stone vault, less volume, that gives you 80% savings right there. And then if you do less stresses, then you add all of that up to 85 because you use a lower strength material. So that means that with today, and so this is fully engineered, we built it already once and we're now developing it to deploy at scale. We already have a solution that is 10 to 15% of the equivalent embodied emissions of a floor plate. So again, looking at this image, realizing that 40% of all the masses in this building, in the floors, this is really something to go for. I had, of course, 100 more slides. I might maybe want to stop here. Yeah, probably. Huh? Yeah. Okay. What's that?
Der Cable. Does this work? Okay.
Yeah.
So yeah, thank you so much. Since we talked about the white elephant, I think I will continue on this a little bit. And I simply put together a couple of facts that might be helpful for our discussion tonight and how we can address these facts. And a couple of them were mentioned already. I think the status quo is also clear. We live right now what is called the concrete conundrum. Karen Scrivener, a colleague from the EPFL, even states that more than 50% of all man-made objects in our world are in one or the other way connected to cement. That means that we have gigantic masses, of course. I'm sure you know this figure, done by the Bill Gates Foundation in 2014, that China in 3 years between 2011 and 13 used 1.5 times the amount of concrete than actually the US did in the whole 20th century. So we have to also understand the scale of this. And I will come back to this important figure. And then, of course, we have a couple of issues, let's say, a couple of problems that we have to address. This one here from a Swiss newspaper, the Tagesanzeiger. You see the headline, "The sand is running out," addressing a global issue, here being Singapore as a case study. The same is true actually for where I live in Germany. Deutschland geht der Sand aus, and I can mention Austria. I could mention whole Central Europe. That apparently we are running out of sand as a reserve. I think that's an important distinction that we have to do. We have enough resources, but we claim or we understand the reserves that we have as that part of the resource that is technically, economically, ecologically, and ethical, being able to be sourced out of our natural environment. And then we know all of these stories. This one, an example of Sierra Leone, but also Morocco, is claimed that they lost already 50% of all of their beaches. Sand is a natural material which comes out of mountain ranges, basically through erosion. The sand is washed into streams and rivers and then washed over 350 millions of years on our shorelines. The last 150 years, we managed, for example, to take that 350 millions of years of erosion material out of these places because our hunger for that material of concrete is immense. Philip mentioned already that the concrete industry, that the building industry, not concrete, the building industry at large is responsible for 40% of our CO2 and greenhouse emissions. And also it is known that, I think Andreas mentioned at the beginning, there are a range between 4 and 8% that the cement industry is responsible for the global CO2 emissions. And I don't have to mention that these emissions, of course, have impact, that we are living in a time that we consider that being a crisis. That has not been the case, and it's interesting to see the exhibition, where the exhibition stops in the 1980s, 90s. That fact was actually not there, and I think that knowledge that we have today, looking back to this one, is an interesting fact that gave basically maybe a freedom to the industry and to architecture that you talked about before, which today is maybe not given. That you said that maybe we have today to apologize even using the concrete, and that has to do with these two facts, right? It has to do with the question of reserves and resources, and it has to do with our climate crisis. The reason why we heard today that we can reduce the amount of CO2 emissions in the production of cement. 50% of the emission of CO2 in the cement industry comes of the firing process. So today, mainly fossil energy carriers are used to heat up the calcium carbonate to temperatures around 1500 degrees Celsius. As I said today, that is not a regenerative energy source. This is basically fossil energy. Even if we claim today that we are burning tires, still it is emission, right? And I think our climate does not distinguish between a prime material and a waste material. The question is, how do we get rid of the emissions? And the second part is a chemical reaction, turning calcium carbonate into calcium oxide and carbon dioxide. That is a chemical process. It's inherent, and as much cement, of course, we produce, more CO2 is emitted. Now, what are our ways out of that, right? And we can address, when we discuss about sustainable construction or sustainability at large, there are three let's say, methods or scenarios we usually look at. And the first one is efficiency. Efficiency could be described as making the existing system better, right? So let's say we have a combustion engine in our car, and maybe in the 1980s that engine used 8 liters per 100 kilometers. Today we are able maybe to build an engine that is only using 3 liters of gas to run the 100 kilometers. And I think Philip right now addressed also a part of this efficiency or effectiveness discussion that comes with it. Basically, how much material do we use to reach the same effect? And that is a very important discussion, and that is one solution. And I fully agree with Philip what he just said, that even in the end, if we reach 15% only, or we can save 85%, to reach the other 15% with other strategies might be much easier. The second strategy is sufficiency. And that sufficiency basically translated into the idea using less. So basically, whatever we do, we should think and we should talk about how to use less, for example, of concrete. And we know all of these technologies, right? These bubble deck technologies, you know that you put these balls into the concrete slabs, so you could save material. Is one of those strategies, or what we heard today already, kind of using a lot of aggregates coming from a recycling stream, so we don't have to use as much natural sand and gravel. That is a sufficiency strategy that we should definitely go for and research more. And then there's that strategy, the third one, which is called consistency. Consistency means that we understand our natural environment as a encircling or encirclers operating systems, and that the human being being part of that circular system. And consistency means that whatever we do and how we act should be in line with this circular system. And now looking at the two main problems that we have, maybe you know this gentleman, Mr. Schellenhuber, who was the former head of the Potsdam Klimafolgenforschungsinstitut. He, I think it was like 2 or 3 years ago, came up with a statement that we should simply not use concrete anymore because of the effects that I just described. But, and I think that's a very nice graph that he shows in a paper published in Nature, that basically the buildings, the built environment should act as a global carbon sink. And you find these numbers again. So he says between 350 million years ago until the year 1750, basically our planet was building up a carbon storage. And that between 1750, the start of the Industrial Revolution, until today, basically what we do is we take that storage and we using this storage, the carbon, mostly in form of fossil energy carriers, and basically emitting that carbon again in our atmosphere. And what he claims is that as of now, we have to go back and build again a carbon storage. And his proposal was that what he calls the Waldbaupumpe, the forest building pump, and using the built environment and using one of the most powerful natural circles that we have on our planet, the photosynthesis, basically that he talks about trees and forests, but you could imagine any growing organism on this planet using that pump to get the carbon again out of the atmosphere and putting it back, in this case, in our built environment. A lot of questions with this. Do we even have enough resource for that? Is there enough wood available? Is there enough natural materials available doing this? I think that's all questionable, but I think it is an important point to discuss, and understanding the mechanism and using, and that's why I'm using this example in the term of consistency, using natural circular systems to take care of our CO2 problem. Then there are solutions already for the idea of using these materials, again, that we put already in our built environment. There's a company in France called Smart Crusher. And interesting with this company is they don't naturally or only recycle the material or concrete, but what their aim is that with Smart Crusher, with this technology they developed, that out of concrete, they can actually get out the natural sand, the natural gravel, and cementous parts out of it, by thereby keeping the original quality of the material on the same level as the primary source. And that is a precondition actually for the circular economy. So making sure that we get all materials in their natural state, in the primary state, back into that circle and not starting to cascade them down and extending therefore the dead end road. So I think there a lot of research, a lot of innovation would need to happen in the future years to come to get that on a large scale. And imagine the amount of material that we already put since 200 years into our built environment, using that as a new urban mine. I think that terminology, urban mining, also applies here. And you can look at these numbers. They even say that using these aggregates creates a kind of a stronger mixture of concrete. I don't know. These are simply facts. Now, but what do we do with the CO2, right? And I mentioned before in the idea of sufficiency and efficiency that of course we can emit less CO2 with new mixes, with the help of our chemical mixes. All of that is possible. But let's say, what do we do with the other 15%? And there also are new technologies out, what we call now the carbon capturing processes. And there's an interesting case study right now happening in Norway. Basically here, the cement factory, the CO2 is captured directly at the source. They put it in, or they liquefy it, they put it onto ships. You see it here, the harbor of the cement factory, and the liquefied CO2 is then brought to an area in Norway where there's a special geological formation, and the CO2 can be pumped back into ground. And with that special geological formation can be stored in ground again. So think of that pump of Schellenhuber. Basically here, it is not the natural pump, the natural photosynthesis process, but here it's a technology that also has to investigate it and maybe can help to not even emit the CO2 in the cement factories. So basically, these are all bits for discussion and thoughts for discussion. There's a lot of ideas happening right now. I think when we talk about the future of cement and where we go, it is not hopeless, but I think maybe we have to question a little bit where we put our resources. So where do we channel a lot of money, a lot of people, brains, and intelligence towards these technologies? And I think we cannot do one without the other. I think the solution cannot be we take one of these ideas, for example, the carbon capturing, and forget about the natural systems. I think we have to work on many, many levels to actually somehow attack the problem we cannot deny that we have today. Thank you so much.
Thanks a lot. So we can start on the discussion. I would like to, of course, address first our speakers who haven't presented yet. Friederike Kluge, maybe you can start. With Countdown 2030, you have tried to put forth alternatives for architects to, for instance, to use concrete, and also, I mean, among other things, suggest alternatives of material usage. Has whatever you have heard today changed your skepticism to this material or not?
No, I'm quite happy about what I heard today as well. Of course, I know there's lots of how's it called? people searching for right answers. This is, I think, also words like sufficiency, losing less. This is, I think, really important things. Also, I was very wondering if we could maybe also reuse those floor panels. This would be my next question to Philip.
That was in the part of the 100 next slide.
Yeah. Yeah, I said you should have shown those one, I guess, because this is very, I think, important to be able to reuse. I would say, you said today you gave us a little tour through the museum, and you said architects are pre or contra concrete. So I think it's something in between. I also wouldn't say you cannot can totally build without it. But I think we have now also search for other possibilities. And of course, today we want to talk about concrete, but of course, there are always lots of possibilities, different ways to build. And I also think it's not one solution we should pick, but see everything we can do. And my problem with concrete right now is that I'm not so afraid of the future. I think we'll find solution. I just think, what are we doing now, as we are maybe not as fast with all those. We don't have already the solutions right now. We are really searching for them. And there's no carbon neutral concrete right now we can use for mass housing. This is my problem. And I think in 10 years, maybe we are also, the carbon capture will be a little bit forward. But yeah, right now the solutions are missing, and we are building too much with this material. So we have to find alternatives that already exist, and there are quite a lot. So this is maybe the next, what we should do right now.
So we have to deal immediately with the transition phase until we have technologies that allow us to build carbon neutrally. Maybe Christine Binswanger, you can tell us a little bit about how Herzog de Meuron is trying to act as one of the globally most important architectural offices with this transition zone. So what are the things you can change right now, or that you are changing already with regard of these to these questions?
Good evening. I think we're not, we, as everybody in the room, as many schools, architects, engineers especially, everybody, I believe, is on the subject, let's say, in our environment. But I think the problem, maybe we could see the pictures I sent you. I think the problem really is laying somewhere else. Yeah, thank you. This is also Egypt. And, you know, when you say, I'm not sure again, I sent you 2 or 3 pictures, but it is really about the mass. And it's about things that happen with not us involved. It is really things, these are pictures, by the way, from Egypt, when I was invited with some other people here to be present at the time Lafarge Holcim Forum for Sustainable Construction. And I was so shocked. So the first picture was when I was finishing my my lecture in the plane, and then all of a sudden I look out and this is what I saw. And so that was really, for me, I'm not talking just about a personal experience, that was really made me understand what the problem is. And we then, you know, also visited these structures from the ground, or these cities and so on. So everything you can do to bring those technologies to these places, that's the only way to save the planet. I don't think it's about us doing a garage more or less, or but to answer your question, of course, we are trying to address the subject of the reduction of CO2 with every project. And in my view, it's going to lead two very differently looking buildings. And I'm looking forward to this, and some of them are in the making. We start to really think differently. It's not about integration of systems anymore into slabs or walls or etc. But I think many of these things have been said.
No, but what are the actual alternatives? So, for instance, are you trying to avoid concrete? Is this any kind of?
No, at this point in time, we have to. Not to avoid, but to reduce. And, it's so interesting what Philip has been showing, and of course also what you have been showing. So, it gives me, the evening gives me a bit of hope, but we have to act right now. And so right now, yes, it's the kind of natural reaction. Okay, can we do without? Or with only in the underground? And then the other thing, of course, is reuse on a big scale. And we do have a couple of projects, of course, in our office where we try to convince people to reuse instead of build new.
But what are the alternatives that you use if you try to avoid concrete? Like, give some examples.
Well, many things have been said. Of course, one is clay, one is wood, the natural kind of components. But we are also in a comfortable situation, and we can do buildings like the Ricola warehouse because we have a client that is aware, and that this is all wonderful, really. And I'm obviously I'm happy that there is these possibilities, but we are in an extremely privileged situation, and of course we are models to a certain number of people, but not to the people who built those things we saw on the screen. This is not going, so it's really up to you. It's not just up to us architects, who know about Holcim. It's really, I would actually like to hear from you, because I was once on the board of the company. And so what are you doing in those outlets that you do in developing countries? Maybe you want to also describe them a little bit. I think those were very interesting elements. This is like little shops where you go buy your 1 cent of cement to build your own house. And so that's where if we can manage to change it there, then I think we make big progress.
Yeah, you're right. We will make big progress as soon as we're tackling the mass market. The point is, tackling the mass market, you need to have your solutions known by the ones that are building this big complex, making sure that resources or recycling resources are well understood, the technologies you were mentioning, the smart crusher. We need to develop all these solutions because you're right, it's in the garage today, but tomorrow that will be something which will be spread everywhere in the world. And in order to make it spread in the world, we need to shout it to everyone, to the young generations, to the policymakers. We need to claim that this is already existing. When we're talking about the very low carbon cement or the very low carbon concrete, it's not something that we have done in the garage. That's something which is available in Egypt. That's something that, but again, we need to repeat it many times in Egypt before the ones that are deciding about the design are integrating the fact that these low carbon solutions are already existing. And I think it's a combined work all together that we need to push. We need to force people changing the way we build.
Still, but we're talking about low carbon concrete. But if we listen to the projections of John Schellenhuber, he basically says by the year 2030, we have to got ridden out of fossil energies. We need to transition until that time. So how about no carbon strategies? I mean, this is again like no COVID, low COVID. Philip Block, I would like to have your advice here. Architects often, or also clients who are really sustainably minded, when they try to avoid concrete, they go for wood as the first option. How do you see the potential of wood to replace concrete?
Yeah. So I think, thanks for that question, and it allows me to say the key thing that I wanted to say today, that it's sustainability is absolutely never a question about a material. Concrete is bad, wood is good is absurd as a statement. It's what you do with the materials. But because there is, call it greenwashing or whatever, but there seems to be an awareness by everyone and an image associated to certain materials, that the entire sustainability debate is stuck there. And this is really problematic. I mean, you now see in Switzerland, there's literally concrete shaming. There's literally very influential clients that ask specifically for competitions that nothing can be proposed with concrete in it, right? Why is that such an issue? Is that really an alternative? Because, for example, many of these projects are medium high rises, and so on. And there you could really start to question if timber indeed is the right solution. Because if you look more carefully at these buildings, you see massive sections, you see a lot of connections in steel, you see that you have to add a lot of weight to be acoustically performant. You need to add mass to be thermally performant somehow, or you have to overboost all the building systems. You have fire challenges and so on and so on. Then on top of that, yeah, by the way, we separate all materials so that every component can be easily just directly reused or crushed without any very low energy. So that is a principle to think of end of life. And in timber, if timber is being proposed as sustainable as a matter of fact for these kind of applications, then we're really hitting into problems in the years when these buildings will no longer function as they have to function, because the more you engineer timber, the more basically you reduce the chances that it can be used at the end of its lifetime in a meaningful way. And so you saw also, Dirk, you brought in this nice crushing, separating. I think it's also indeed, like Edelio says, it's also a challenge of communicating this, because there's many cute startups that make a lot of noise on that, but the big players like Holcim have all of that already in their portfolio. It's just about actually people asking for these kind of solutions. So I'm afraid of now this stage of reaction and making it about material, because it's entirely going in the wrong direction, entirely. A material becomes sustainable if you use it in the right context, in the right ways. I gave just one example. I called concrete an artificial stone. And I just wanted to give one case study with a floor, what that could mean. So if we now take all materials, what they really wanted to be, timber construction never wants to go high. And you see, it's basically, it's just a green image, and you compensate it with all kinds of things. You see them, for example, the very nicely provocative and beautiful prototype that you did, Hortus, with Herzog and de Meuron. You see indeed what it means when you don't go for engineered timber, right? Then that means that you need to have small spans. You need to, then you have these nice earthen vaults in between. So thanks for adding arches, very good. And to putting it on the Swiss scene very clearly. But that is a repercussion. And today we don't have that sensitivity. So people say we want the same spans that we're used to, and so on and so on. We want high, and we want it in timber because then I'm green. No, absolutely the opposite. So I just reject, or I want to oppose or heavily contest any discourse that focuses on material. It's absurd.
Would you agree, Dirk? Is material...
Well,
does it not matter? Does matter or not?
No, I think it does matter. I mean, what Philip said is fine, right? So it's clearly that also in terms of design and understanding the material, understanding the possibilities of the material, understanding span, width, and all of that, I think is key to any discussion that we should have when we talk about sustainable construction. Nevertheless, is the fact that we have a problem. And the problem that we have has to do also with the material, and you mentioned that, that when we look, for example, today at the timber industry, I'm not quite sure if we can even call it timber industry. It is a timber industry that uses a lot of synthetic glues in order to achieve these large spans, or to cope with with the loads that we have in structures. But we even do it on the level where we have OSB or particle boards that contain up to 10% of non-organic synthetic elements. And we talk about a future industry that is circular. I think our profession has to simply do a paradigm shift, meaning that whatever we construct today, and we saw that 80% of the buildings will be there still in 2050, whatever we construct today cannot be understood as a linear process of take, make, and throw. That is how it's done today, right? Look at our phones, right? I mean, you can not even open these things up, exchange anything, because they are meant to be thrown out after a couple of years. And that is very much true for the building industry. When you think how we, as architects and planners, until lately designed, is that as you said, we integrated everything and how many glues we use. For example, when you think of waterproofing a cellar, right? That you had a lot of bitumen, and then you put your foams, and then you put your waterproofing, and then you put another drainage layer, and so on, so on. So when in 50 years from now, we would like to recover these materials, we cannot, because they're all glued together. We cannot recycle them. You could not even bring them to a recycling agency for aggregates, because you have too many particles, which the European law does not allow to have in them. So by making too many mistakes in design, and I think waste is more or less a design problem. It is not a material problem. So therefore, I agree that the material is maybe not the main focus, but it depends on how we put it into our buildings. That is the important question. And if we understand a building as a temporary storage of material, so that future generations can take these materials in their original state, that's what I said before with the sand, the gravel, and the cement, right? Mm-hmm. In their original state out of these buildings, and either reuse or reconfigure these materials, I think that is a strategy we should definitely follow. And that includes concrete, but it includes any other material that we can think of, right, in the building industry. That is easily said. Now, think of yourself. When we plan, right, when we plan a wall and we plan a window, we use a lot of wet sealants everywhere, right? That is actually a no-go anymore in the future. We use a lot of paints that we put on, which cannot be scrapped off. We use a lot of foams that we put into our buildings, right, to close gaps and whatever. We use a lot of connection systems which are not being able to take apart. So all of that, I think, falls on our responsibilities as planners and architects to think in our design already of the afterlife of these buildings. So I question, for example, why we do not file a disassembly planning for our buildings. We only have to file a construction planning. We never file the dismantling of these buildings. Why not, right? Why do we pay for materials which already come out of the recycling aggregates? Why do I have to pay for a concrete mix that holds, I think in Switzerland, you're much better than we are in Germany in terms of the mixing of recycling aggregates. A concrete that contains 60% or 50% of recycled aggregates. Why do I pay the same tax for that concrete than to a concrete mix that uses only 100% primary resources? So I think we have to come into a discussion how to favor the idea of a circular industry, the idea of not gluing our timbers together to an unsolvable problem, because what happens with the OSB and with the particle and with the binders that we have, in the end, it's a cascade using, right? We are in the worst case, they are taking out, then we put them in little small pellets, and then we fire them, and then we call it even thermal recycling. Let's be honest, that is a destruction of the material, plus with the immediate release of the CO2, which we claimed before that we store it in our building. So number one is we have to know the problem, and number two is we have to be honest to each other. And we have to look at the whole building cycle, right? The life cycle of these materials and of the building elements. And if we're honest to each other, I think then we can tackle the problem. But if we keep on, hiding a little bit here and there, and then we will never ever be able to make a change. Thanks.
Go ahead.
Yeah, maybe you know, I think this leads to starting a building, and there were times before that where that was the case. We start the building from the detail, and it's very interesting with Hortus that we developed the systems of how to build this, and you know, and its environmental components.
Please hold the mic to him.
Before we knew how the building would look. And that's the one thing I think is a consequence, that we have to really completely change the design process, also how we teach. The other thing is, of course, I'm not so good at numbers, but I think it's something like 20% to 80% of the emissions that a building creates is in construction and then in use. And of course, what you already said or touched, I mean, to change the expectations that what our buildings do, and to get away from what we did in the last you know, half century to our buildings and their thermal behavior, their I mean, it's crazy, and we just realize right now still a lot. You know, people are now thinking, okay, if we can make it out of wood, it's going to be fine. But to tell them that they cannot have those expectations on the air composition, on the temperature behavior, and so on of our buildings, on normal buildings. I'm not saying we have to change that in the hospitals, but if we could change those expectations in housing, offices, working, I mean, that would have a huge impact on the 80% that we consume for having these buildings in use.
Mm-hmm. Philip, you had a comment about?
Well, yeah, just that I agree that we have to kind of maybe change expectations, but we actually theoretically have a solution for the operational energy, and it's just by going to green sources, renewable sources of energy. The bottleneck really is the embodied emissions. So what you're talking about is actually already solved, unfortunately. Some other things are driving it. So I'm talking about, yeah, I just want to differentiate that. By the way, I agree with everything you say, that we need to, again, have also passive systems, and that we have to adjust our expectations. But the emissions associated to providing energy, heating, whatever to your building is theoretically solved. We have enough energy on this planet, the sun, the wind, water, and so on. It's just where this comes. So that needs to be steered top down. That needs to, like what Dirk said, how can it be that you're taxed the same on solutions that help versus solutions that don't help? So I wanted to nuance that. I think we have a bigger challenge with the material impact of construction.
All right, there's a couple of questions from the audience that Andreas can bring in.
Yeah, there's a lot going on. There are more than 200 people following us, so they're very glued to the conversation, and they seem very enthusiastic about what they've seen and what has been presented. But I can maybe sum it out with a little bit of skepticism that the things we have seen or that were discussed, that they can really reach a very wide audience. Like, for example, Igor is asking about the availability of these solutions to countries which have no access to the latest technology. Joel asked about the price of these new solutions. Are they more expensive, and therefore some people cannot access it? Katerina said, how can these discussions not just be scientific, but be part of the process? So there's a bit of fear that these things happen in a bubble, and that in some countries, these things may also not be imposed to certain industries. For example, Manuel, who lives in Mexico, says, how can we push governments to ask for this? I think it's more or less also the question Christina asked to Edelio, how can we get this out there, like to the whole world and not just to a part?
Yeah, first of all, we need to think not only for the more mature countries or whatever, because I was presenting some cases that are today implemented in emerging countries. So we're not only talking about the most mature with the latest technologies, and some latest technologies can be easily available in emerging countries. Just look at the iPhone. Just look at your your technology that you're using today, they are very well spread everywhere. So the way we are managing today our innovation is the same in Mexico than in Cairo, than in Switzerland, first of all. The second point is that a lot of the resources needed for these innovations, we were talking about circular economy. The same way you can do it in Egypt or in Cairo or in Mexico, the same way than in Switzerland. It's a question of regulations first. It's a question of making that known in these countries. And we're spending the same energy today in Mexico than in Cairo than in Switzerland to make it happen. So it's more how to make sure that the technologies, which are in some areas quite simple to implement, are done on a voluntary basis by the policymakers. Regarding the price, I think here the point is that we need to accept that if we want to solve some situations, we need to invest in new technologies. We were discussing about carbon capture before. Yes, definitely we can run net zero plants by 2030. By the way, we have 6 examples that will be running net zero in our group. The point is this technology today available everywhere? The answer is yes. Is the customer, is everyone ready to pay for it, ready to pay for a new technology which is costing a little bit more? I question this. But the answer has to be yes. Yes, because we need to change, and we need to change it now. So incentives from some countries, some from governments, from customers, from ourselves, and definitely the demand will make that happening.
But how can we make this change happen? I think it's interesting that we don't talk or didn't talk about politics so far, not about the role of governance, of actually kind of an induced paradigm change. And I'm wondering, especially Friederike, you've been trying to identify fields of action and change that architects can intervene in. But how much can architects do, and where do you think the overall paradigm shift would need to be encouraged by a different kind of set of political regulations? Or can architects just go ahead and just do it? Is it just a question of knowledge, as Edelio was saying, that people don't know about these structures, and that will it do the trick if you popularize that knowledge of what can be done differently to just make that change happen until 2030? Or do we need an extra push, actual coercion from political strategies or agendas?
Well, we thought in the beginning, yeah, there's lack of knowledge, first of all. That's why we started to talk about it, wanted to know more about all different fields. We talk about every solution, but what we wanted to do in our group was to really have a change right now. We don't want to always project in the future and say it will be better. We will have the possibilities to do this or that. We want to construct, right now what we can do to really have an influence and not talk anymore, but get into action. And then, yeah, of course, we found out quite soon that our possibilities to use greener solutions are sometimes not working if politics are not in this way as we need it. Also, the clients, we have the problems that, for example, that clients don't accept this way of better concrete, or yes, for them too expensive, and they say, okay, we go to with a less expensive version, and that's a really problem. So we cannot push them as much as we want. And of course here politics come into play, and we found out as a group that we really have to also be pushy at this place, because it won't change. We don't have the possibilities to reach out. And I also find out that now architects are getting way more political as well, because I think we noticed that we can only change things if we really start changing regulations and how much the fees are for each material solutions. Yeah.
Mm-hmm. Just if in case you have questions directly here in the audience, just shout out. There is one. So we need to get the microphone up on the top space.
Thank you very much for an interesting discussion with many insights. I have a very simple question. If there is good concrete and better concrete, why don't we ask governments to just ban good concrete so that the better concrete can prevail?
Well, it's an interesting discussion, right? Because when you see now Germany, they claim for the new government that they want to build 400,000 living units per year now in Germany, which is doubling the amount that we did over the last years. And a lot of us asking the question, how, right? Where do we have the manpower from right now? We don't have the possibilities to build so many flats, and we don't get any companies to actually do the work. Where is the material coming from for such an endeavor? Where is the energy coming from such a huge endeavor? And if we do this now, every year, 400,000 new building flats in Germany, I ask the same question, shouldn't we do it right? Isn't that something, if we do it wrong right now, falling back on the feet of the next generation? In terms of CO2 emissions, in terms of not circular building technologies. And that is really a major question we have to address, right? And I know in Switzerland, there were discussions about the building moratorium. I think that's on the other extreme, right? To say that we should not build anymore. That would be the same if you would ask anyone not to breathe anymore. So it is a emotional and very difficult situation that we are in. There is no easy answer, and also, funny enough, there is not an easy answer to say there is a good concrete and a not so bad concrete, right? I mean, not to go into detail, but it depends. I mean, you mentioned it in the very end, and I think you were very honest about that you said that you want to reach net zero, right? But we know also there is cross zero, and the cross zero numbers are not looking that optimistic as you showed here. So there is this, we don't have the easy recipe to say.
Maybe can you explain the difference between net zero and cross zero?
So let's say, if you correct me, okay, if I'm wrong. But lately there is the idea, and I think it is also practiced very widely. For example, instead of burning coal in cement factories to reach the heat, that you take old car tires, because they burn also at high temperature. And then if you do the calculations, the so-called the netto zero emission, you can deduct the coal emission that you had before from your calculations, because it is a waste product, the car tire, that you, instead of incinerate somewhere in a municipal waste bin, you do it now in the cement factory. That's a common practice, and I think understandable what you do. But as I mentioned before, that was a small hint. Our climate, doesn't care. Yeah, doesn't care. Our climate does not differentiate between if the CO2 goes out in the chimney in the incineration plant or in the sand plant, and therefore, if you calculate the full package of emission, that is called the cross zero, or the fly ash, right? The fly ash is a product of when you mostly burn coal. Yeah. And of course, if you simply say it's a waste product, and I add it now instead of cement, and I do not add the CO2 package that comes with it, because the CO2 was burned with the coal, then of course you can reduce your net zero, and that is fine. I think as long as we claim it is net zero, then we are all fine. And I was very happy that you said in the end it's the net zero that we saw here before. The cross zero is the whole calculation with it.
Correct. And the net zero is the ultimate goal for every kind of industry, because in fact, using waste or tires, etc., anyone or everybody has to manage these tires. So otherwise they will just finish in the landfill, just destroying the natural resources we have. So having this solution for the tires, having the solution for the alternative fuels that are waste today, that they will be used. But on top of that, and this is the holy grail that we're reaching today with carbon capture, just making sure that we are not emitting at the end the CO2, whatever the source of the CO2, be it the alternative fuel, the tire, the coal, whatever, we need to avoid the emission of this CO2 by capturing, which is the technology that the industry has to use as soon as possible. For the sake of time, I had no time to present the very last two slides, but we consider that half or close to half of the solutions to get to net zero will come from the use of the cement itself. Less clinker in the cement, less cement in the concrete, and less concrete with the solutions that Philip was showing before. That's part of it. The second part of it will be just to avoid that the CO2 is emitted at the chimney with the carbon capture. Recarbonation, we have mentioned that a little bit today. That's another part of it. So that will be a bench of solutions that all together will help us to reach the net zero. But again, back to the point on the bad or the good concrete, I would define that the bad or the good concrete has to be looked at the use we're making out of this concrete. Too much concrete will never help. Just having too much or too good cement for masonry, it doesn't help. So here again, it's about very much communication to the masons in Mexico, Cairo, etc., to use the right cement for the right application. Not too good, not too intensive in carbon if it's not needed, and the right one in order to sustain or to have a sustainable and durable solution. So here again, my comment just to finish on this one is that's a bench of solutions and communication on the best use of this material.
Maybe one other question to answer, or maybe also provocation into this group. I don't think we can ban, maybe we could, but another way to do it is to have the right price on CO2. And I don't know, I believe in this. I think if that price goes to where it needs to be, that the good concrete becomes cheaper than the bad concrete. But of course, it's a big exercise, because then it's about redistribution of this money that that is raised through those prices that will make the economics, lead the building industry into the right direction. I'm sure there's other people that have an opinion on that subject.
Did your comment relate to this, Philip, or something else?
It was triggered by it a little bit, because actually what drives people more than sustainability is, of course, what it costs at the end of the day. So that's what drives, and particularly also in reaction to the question on how can these things make sense in other parts, and they look also high tech and so on. I tried to show that actually everything we do is not high tech. It's actually reintroducing these common principles that make sense in other things. And why I wanted to speak in context of that is that we are now, I didn't show it because it's in progress, but we are doing a large developments in India. Large developments with, a prototype for a large development with the government of South Africa, where we're going to start working in Kenya. Always large developments for whom? For the lowest cost. And so why we introduce these kind of principles of reducing, placing, using local materials, concrete-like materials, not the typical concrete, but something that can be cast, that can be placed and so on, is actually the drive is low cost, and then you get the sustainability targets actually for free with it, right? And so in that sense, I think we need to do more of that, actually addressing the real problems, where the real problems are, which is in the developing and so on. And I think what could be an effective trigger, or at least that is now seemingly for us very effective, is actually to address the real problems of low-cost housing, and with that discipline that then brings these additional benefits. And then maybe one thing about, I also obviously again agree that what we do is not the same impact as what needs to happen in a developing and so on context, but nonetheless, the world is looking at us, is looking still at Starchitects, is looking at Switzerland as a lab for innovation and so on. And also in this developing context, we all hope that they will leapfrog and not make all the same mistakes we made, but they are also wanting to live modern, new, have glass towers and so on. So I do think that we do have an extremely important responsibility in leading the way by example, even though yeah, so we need to challenge ourselves also and take that responsibility. And then lastly, we have another big challenge is that we are all talking with such a, it's obvious that sustainability is the thing that is here in Europe the case, but that is not driving at all. In the US a little bit more, it's coming up, but in many parts of the world, in Asia and so on, sustainability is not really on the target. And so that is why I wanted in this context to talk about the need, about low cost and so on, so that you can achieve sustainability through another means, through an economical kind of viability means. Yeah.
And obviously, if we address the mass and the local production and the large amounts of production, we also have to say, okay, my statements are all non-scientific because I'm just a practicing architect. But I think, you know, part of the problem of course comes through globalization, that we have started to produce buildings the same way anywhere on the planet with the same companies all across the planet, etc. And I think if we talk sustainability, we also want to address, you know, social aspects. We already touched the financial ones, but, you know, we made this project, which is a tiny little project in Brazil, where we did exactly what you described, you know, produced concrete-like elements with the local community, and the kind of, what do you say, identification of people with this is huge. And I think this would be also a large kind of magnifying aspect if one could start producing such things at a bit of a larger place. So I think there's a responsibility of the building industry to introduce those methods locally.
Just, Edelio, just before we continue there, I would like to intersperse again with our audience out there.
Yeah, there's so many questions, but I nearly need to iterate what I said before. It's really, I can maybe resume them with some sort of impatience and skepticism. Probably also what Friederike tried to generate with us with Countdown 2030. Things have to happen now. Everyone is conscious that new ideas need more than 5 years at least to be out there, to be approved by government. So yeah, legislation is too slow. Clients don't want to invest more if there's not, there's a fear of new solutions. There's the fear also that this discussion is staying in a bubble, and if government is not giving incentives, that nothing is going to happen. Can you, I mean, in your daily work, you are also having an exchange with governments or just with the industry or clients, or what is your feeling about this on legislative layer?
If I may on this one, first you need to show that it works. In order to convince the governments, you cannot just tell them do it if you have not done it before, if you have not tested it before. Just an example which is back to emerging countries and testing and taking risk. Just a very, very simple example. Today in sub-Saharan Africa, we're testing the construction of houses and schools with 3D printing in Kenya, Malawi, etc. I remember the first time I proposed the idea, people were just laughing because, okay, guys, this is for Germany, this is for Switzerland, this is for, but not for these countries. Today, the solution is cheaper than a conventional housing or a conventional schools. There is a need for schools, there is a need for housing there. We're moving there with a technology which is could appear as a very sophisticated, but it has been tested before. So we are taking this risk in order to show to the government, the local authorities that, hey guys, you can do it, but now you have to do it by your own. You have to test it, you have to, etc. With local materials, technologies well proven, etc. So my point here to the local governments, first, we need to take the risk to test it. We need to show it works, and then we need to convince by, again, I repeat, communication, communication, and communication. That's the key point.
But who takes that risk?
We.
Is it, but who's we?
The one that want to be the leaders, the one that want to take the risk, the one that believe in it. When I'm showing that in 2030 we want to be 6 plants, net zero, etc., that's we are taking this risk.
No, but in a concrete project, is it a client? Is it the architect? Who takes that risk?
Everyone. The architect that was okay to build this 3D printing housing in Kenya and Malawi, he was taking some risk. He was the first one doing this house in 3D printing. The robot player was taking the risk to go there. We were taking the risk to test this in Malawi and Kenya. Obviously, it's simple in Switzerland or in Zug or in Zurich or whatever. But if we don't push for these solutions, if you don't take risk, if you don't collaborate with the academics, if you don't collaborate with the startups, etc., etc.,
but does it
no one will move. No one.
Does it also mean you take a financial risk? I mean, do you invest money that is actually for stuff that's
for sure. We test.
But at the same time, you were also saying that you're trying to reduce the amount of concrete that you're using. That also that means you reduce your profit. So from which money do you take that money that you risk then?
But why are you talking about profit?
Well,
the volume is not. No. Sorry, the volume is not linked. The volume is not, the profit. Sorry, is not linked to the volume.
So that means your new solutions have to be more expensive than the ones that you're making more efficient.
Have to be more efficient at the end. Globally, at the life cycle analysis, when you do the life cycle analysis of your product, it has to be more efficient and more profitable. Obviously, we're not there to lose money. But the point is that if you start thinking the design of your building being circular, with the idea that I will be reusing everything that I have in my building, you're already anticipating that in the future, this material will be reused, not just landfill. Landfill is a cost for nothing.
No, but it's I understand that, but if you're saying that basically you're trying, and you showed the numbers, you're trying to reduce the amount of material that you use, right?
Yes.
You try to make concrete more material efficient.
Correct.
To gain the same goal with less matter and stuff. So that's great. So, but that means by volume, if you sell by volume, you have a decrease, and that means if you want to keep your money income, you need to increase the price, and that cuts back to the question that some of these people asked. Well, are these technologies actually affordable to countries that are poorer?
The answer is yes, they are affordable. The example of the 3D printing is affordable in these countries. The point is that at the end of the day, are we making money differently? The answer is yes. You will be selling less volume, less material, more service, more technology, etc., etc. The answer is definitely yes. Yes to the point that can we still make money? The answer that will be definitely yes. Mm-hmm. You can be sustainable and profitable.
Dirk, you have worked in Ethiopia, for instance, and you developed a prototype of also a house prototype, a domestic prototype in a shortage of housing situation in Addis Ababa, and you tried to use mostly locally available sustainable materials, which was mud mostly. Is your experience similar to Edelio's point that basically the technology, the availability and the affordability of the technology is not a problem in such a context? Or why were you then working with a material that was basically there for free?
Yeah, it is a very complex issue, right? And it's the same complexity that we have in Europe here right now. I just mentioned the social housing program in Germany. That the name itself says already it's a social project, right? So affordability is part of a social discussion, and it's not more or less a technology that is functional and working that our people or governments are interested in. It is the question: can the lower income people afford to live in such structures? And I think Justine said before that of course concrete has the big advantage that globally seen it is a rather inexpensive material. And it comes.
Is it too cheap?
It's maybe too cheap because it comes with a high price,
Mhm.
right? And that high price is not seen, funny enough, as also a social issue because it comes later. It is not immediately tangible, and it's not immediately in our faces in order to be seen as another element in this discussion. And I think that is the problematic discussion we have. And looking into these into the developing territories, they actually would have a huge advantage. That is what Philip mentioned, is energy. Right, so even we here in Central Europe, we fight for achieving now whatever 50 or 40% of renewable energies, and every other percent is hurting, right? Also socially, do we want to have these technologies visible in our landscapes? Is a big debate right now. Can be afforded in terms of rebuilding a complete infrastructure in Central Europe? And here I saw, especially also in territories that you mentioned, that, for example, that could be a huge advantage. As I mentioned before, 50% of the CO2 emission is generated by firing the limestone, right? So here I think technology, yes, can help on a large scale, right? And therefore, the question is maybe not so much on the level of that neighborhood seller of a bag of cement, but we need the governments to change, for example, and I think we should help with this, to change to 100% renewable energy sources. And that might be advantage because a lot of these territories do not have an existing infrastructure. So changing ours is super hard, but starting from scratch might be easier. There's a very good example in the cell phone. I don't know who mentioned before. A lot of those territories never had landlines, right? When the cell phone came, they did not go the way through the landline telephone and then 10 years later adopted the cell phone. They immediately jumped to the cell phone. So I think that can be a role model also in bringing in technologies and then we learn from these territories back to the north. That is a much more interesting discussion than understanding ourselves in that driver's seat and saying whatever we do, everybody else has to do. That might be a single-sided view. We have to look in it both ways. And then I think innovation should happen, as you mentioned before, also in terms of the resources that we use, right? And new chemical compositions. I mean, I think also we are on a limit. There are only 3 elements on the Earth crust that we can use to build cement with, or to create cement with. But I think the innovation that could happen also here in our territories, and that's what my claim would be, right? That I say the word, the profit that we do here in the north, shouldn't we push much more into innovation, research, and development? I think that it is necessary, right? Philip mentioned that there are technologies that we can reclaim sand and gravel and cement already from existing concrete structures. I don't know of any. I mean, I only showed this one right now because it was the only one I know so far of, right? That really claims in its original state, not in a conglomerate. So I think it is a difficult discussion because the social element is part of a sustainable debate, and we cannot neglect that these houses need to be affordable, that need to be safe, they need to be in mass produced. And then we see what you showed in Egypt in these mass housing projects. They don't happen out of nothing. They happen out of need. And we have to answer that need.
But actually, and that's just another dimension to it, we learned when we were there that what we saw, very, very low occupancy. This is not housing. I mean, that might be a specific case, but this is not housing that was built because it was needed. This was housing that was built in order to invest. Yeah. And not just the big ones, or even the people who buy, they buy it because the inflation is too high. So it's safer to buy a piece in those things than to, put the money on the bank. And so that happens in all kinds of dimensions and places.
This iterates also what some users were posting, not as a question, but really as a statement. there's really the consciousness we have to consume less, we have to travel less. It's not about only reducing CO2, but also water consumption. And I think there's Manuel, he sums it up very nicely. He says, no matter how, we must build less, or we must build with things that materials that are already there. But this is not a question, it's just statements that came up.
But it gives me an opportunity to ask Frederic again. Dirk mentioned before the Abriss moratorium, the demolition moratorium that was started up, I think, last year by a couple of people, mostly in the academic world. Would you say that's possible, to say that as long as we have existing buildings standing vacant, there should be a ban on building new stuff? Do you think that's practical?
Well, yeah, it was a moratorium on new buildings, not on total construction.
Sorry.
Yeah. I think this is really very important also to say. It's totally complicated. I think if we see 400,000 in Germany, for example, but also worldwide, we need a lot of places to live in. But still, I like to talk about it, to really mention it, because it says, hey, we have a problem. Also saying, okay, concrete is really bad. We said it for a moment because it just woke us up. What is happening? We shouldn't build anymore with concrete. What does it mean? When Schellenhuber, for example, said this, which came from, which was telling us we have to change our routines. That's, I think it's interesting. And I also think the moratorium, maybe we cannot do it everywhere, but still I think we have lots of possibilities while changing our routines, because there's so much stuff that can be done and actually we are not doing it. And also the discussion about sustainability, sometimes for me it's really a narrow way. Right now I found out sustainability means that we really have to have a holistic way to look at things, to discuss possibilities are not easy. It's really not clear what to do. It's not black or white. We have to find out the right system, which is the material that we use concrete where it has to be used, maybe as in the floor, in the fundament, but this doesn't mean we should avoid the cellars if possible, for example, that we really use the material, as you also said before, how it should be used. And I think there is lots to do. And I think this is where we right now have to focus on. And this is what also maybe the concrete has right now as a problem, that it's also the way how we recycle it. And it is now recycling a lot to go in road construction, for example, which is the next problem. And also, therefore, we should not only focus on wood, because we will have the next problem if we just say, let's go for wood. So actually, we just have to get more information. For me, education is a very central part. We have to talk in the schools. We have to talk here. We should talk every time, and also as practice in architects, where we don't have lots of time. Look how we can get the knowledge into our minds while designing. That we see that it's a really big problem. We have a bit talked about the sand, or we have a bit ecology is a very fragile system, and I think all time when we build, we get into these systems and we have to be more aware of what we are doing. So coming back to the moratorium, which you said, I think it's really telling us, let's think whether a possibility in our daily lives to change something. And of course, the structures we already have is a big possibility to reuse them. And for concrete, as it's really in one shape, we maybe should also discuss prefabricated concrete. That's what I'm always questioning. Would it be, you said you would destroy your elements. I more thought about reusing them. Reusing, okay. As prefabricated elements, that we can have more flexibilities as well in our buildings, that we can dismantle them and we don't even have to crush them, but we can reuse the elements. Maybe this would be even easier.
Mm-hmm. So we have to come to a close because we're getting cold, because we're so sufficient here that we don't heat this space to death. It's very good. So I'm wondering, Philip, maybe you can sum it up a little bit. I'm wondering, what do we learn from all this? Do we learn that Mies van der Rohe is still right? Is less still more? Is that the basic option? I mean, do we basically have to cut down our production in order to reduce the footprint? Or maybe this question, the two key concepts that Dirk brought up, is efficiency bringing us there, or is it more sufficiency? And these two seem to be fairly different as protocols of action.
Yeah, it's going to be a combination of all the above. I think what Dirk's message and what we all try to say is that one solution doesn't fit all, and you need to understand context, which includes social, which includes all these aspects indeed. But if I may, I wanted to say one more thing to earlier. We need to indeed shift from volume to value. Everything in the profession is around volume. Your fees are calculated on how expensive the thing is. How expensive it is related to the resources first and foremost. We have to rethink how we work together. You mentioned this as well, that in education, that we have to bring people together. There is the century or longer discourse that architects and engineers need to talk together. Isn't it crazy that they barely talk to each other in education, and then they have to work together as a good team in practice? But then additionally, we don't talk about the real bottlenecks in construction, in building, in actually proactively thinking of separating material, making them separable. So education is a total bottleneck. This fee structure is a total bottleneck. Liability is a total bottleneck, that we pass on responsibilities to the other. So there's so many bottlenecks. So we really need to restart, and that is why at ETH I'm increasingly vocal that I think I need to start a new department and just kind of start hiring from scratch.
It's the bottleneck department then.
Also, yes.
Yes, okay.
Yeah.
It's great.
Departments, already that there is departments is already a bottleneck, yes.
I want to give the last option to the public. There is a question up there before we are trying to come to a close. Valerie, it's on the very right top corner.
Sport.
It's a great name though.
Thank you very much for the presentation. As an introduction, I have a pleasure to work for the office whose founder constructed this building, and I wonder myself if this is a reusable building. Actually, if this was done in a manner that you can deconstruct it, I don't know. But it's a great space we are in, and we like to be here. And maybe it's a different strategy. But the question is rather different. It's about, maybe I didn't get it clearly, this net zero and cross zero strategies. But I understand from what Dirk Hebel said, this cross zero is a very interesting concept. It doesn't matter where the CO2 is emitted, but the goal is not to emit it. So maybe it's better to keep some materials in the landfill than to burn them and maybe create some less CO2 cement or concrete. Am I correct? Like, is it maybe better that we in the future use these materials from the landfill and not burn them today because we have 2030 to go?
That might very well be a strategy. I think if we don't have technologies yet to take care of these materials, it might be that we have composite materials. A car tire is a highly complex system. You have metal in there, you have rubber in there, you have glues in there, you have textiles in there. And we have no technology yet on the market that can separate the rubber from the glues, from the textile, and from the metal. So what we do again, when we burn them, we burn the resources, right? So we destroy it, and what we get out of it is emission. So it might be one of the strategies to say, unless we have technology that brings back all these materials to the original state, we rather take it to the side and wait until we have it. And not burn it, because we have the CO2 emissions and we have the toxic waste that come with it. But now, again, sustainability is a complex issue, right? Now you say, well, keeping it in landfill might also be a problem because then we have maybe leakage of these toxic elements and we destroy other environmental systems. So for me, the solution needs to be every product from today on, from tonight on, every product that we design and build has to have a circular mentality. We need to stop to produce waste, and we need to stop to burn our fossil energy carriers. That is the message. And I know it's easily said, even the European Union said we need to enter the circular economy by 2050. Yes, they said that. They did not tell us how. So here we are tonight, and we're discussing the whole evening about the how, because we do not have the answers. And believe me, I don't know who said it right now, will not be easy. Our generation is facing a problem that no other generation before ever had. I said before, in the 1980s, 1990s, where I was educated here in an architecture school in Switzerland, it is true. We did not have that concrete shame, right? It was clear that we could use any material, mostly concrete, for our designs and for our strategies. We had not a problem with it. But today, we, through knowledge, through scientific knowledge, know we do have a problem. But we do not have the answers yet. But I'm convinced and I'm sure that keeping our primary resources separable, how do you say the word? Sortenrein in German. That we keep it in this stage enables future generations that come to deal much better with this problem that we can deal with it today. But if we close our eyes today and say, well, it's running okay, right? It's running okay. Then I think we will hit the ground very, very hard. And I think, honestly, we still might experience this.
Mm-hmm.
Just to have it put in different ways, I think that question or comment that was made by the gentleman in the back there does say something that is also very true for architects and people who build things. If you build well, you know, that's when buildings stay up, and that's when we use them for centuries. And the fact that we are in this 50-year-old thing and we think it's amazing is very sustainable. And so that dimension we also need to address, or shouldn't be ashamed to address, to make beautiful buildings that are loved on a long run.
What a fantastic closing statement. Thank you, Christine. Okay.
Just perhaps if I can say something else, and the last word. I'm inviting you all to come to the innovation center that we have in Lyon, just to keep discussing, sharing, and communicating on these solutions.
And you
That's
can
it.
see La Tourette on the way, you know. Mm-hmm. Great.